Hello viewers, my name is Prasanjit from NOAA Star and CSU CIRA. I'm happy to contribute to a coastal application spearheaded by Paul DiGiacomo, the Chief of our Ocean Division, and partners from other organizations. This is a short presentation for a poster. We'll just follow the sections in the poster and discuss them very briefly. In the related poster, I have provided a brief update on the web-based knowledge hub for coastal awareness that I introduced last year, October. Currently, the AKH represents an alpha version of a prototype designed for assessing the dynamic state of our coastal areas, employing satellite observations, in situ measurements, related multidisciplinary data, and also research-based higher order information with the vision to contribute to coastal awareness and possibly restoration efforts. The names from NOAA contributors are included in the authors list. As such, the work is part of a larger collaborative effort involving organizations like ISRO, JPL, Geoscience Australia, and others. This slide shows the landing page of the tool, which is hyperlinked from the main descriptive page. It shows the various types of information available simultaneously in the hub. We'll see a little bit more in one of the subsequent slides. The goal of the tool is to contribute to coastal awareness and safety. So to put in context the word safety, this word cloud here summarizes events threatening our lives on the coast originating from various parts of the system model, including human actions and atmospheric influence. The prism graphically explains why the name hub is used. From data, visible, infrared, microwave, etc., information is extracted in the form of physical and biological parameters such as SST and chlorophyll A. And when we observe something uncommon such as El Nino, La Nina, storm waves, HABs, those are all examples of knowledge in this context. This is a simple graphical display of the overall concept. The sea to land and land to sea processes involve various physical, biological, and ecological aspects of the coastal environments and habitats. When they impact the coast, we can say that there was an event. Physical environments can be understood in terms of sea state, SST, winds, etc., flooding, inundation, geomorphology such as shoreline, bathymetry, and hydrology. The biological, ecological, or biogeochemical environments can be characterized by indicators such as chlorophyll A, seagrass, mangroves, etc. Other phenomena like plumes, oil spills, and slicks can also affect the habitats. Also, social indicators are needed for this kind of study. The infographics block indicate that these data, they go into the system and generate specific visualization and analytics. The output includes map visualization in an integrated way. Some are available already and some are in the pipeline, and they're viewable on a public-facing web page. Moving on to the infographic elements, that is the type of information needed, including satellite and non-satellite sources. We talked this last year, so I want to repeat briefly about the main headers and colors. In light blue, we have satellite ocean products. Non-satellite data fall into two distinct groups, curated in light brown and contextual group in light green. These data complement satellite data. In deep blue, we have higher order information based on research, either in-house generated or available publicly as reviewed publications. These include ocean parameter trends and coastal land loss gain rates. We'll see a few examples from this block. This slide highlights the tech implementation part. I'll skip this one in the interest of time. You can visit the web page to look at it at your own comfort later if you're more interested, or reach out to me. So now we'll look at a few specific examples of derived information or higher order information. In this slide, the top image shows habitat suitability index for subaquatic vegetation, namely seagrass, derived by combined use of various parameters from WIS data such as SST, chlorophyll, and others. There is a simple split functionality to visually compare across different years. This work is done by one of our colleagues, Rachel, listed on the slide. cover slide, and a report will also be available sometime soon. The bottom image shows the rate of land loss or gain in the Mobjack Bay Area. These are derived from Landsat data, and the display is interactive vector data, meaning that you can click on each point for further information. This work is also published by one of our talented colleagues, Nikolai Neslin, and the link to the paper is provided here if you want to explore it. We have seen some current state and some historical trend. Now let's see some future projections decades in advance. On the left, what we see is a projection to year 2050 of episodic extreme events due to sea level rise for various RCPs or representative concentration pathways, or simply different climatic pathways. This is based on an external paper published in Nature, and the DOI is available if you want to explore. Likewise, mean sea level projections will also be included in the AKH from NOAA and IPCC reports. This slide shows maps of decadal trend rates for SST, chlorophyll, A, sea level anomaly, and sea winds. Trend lines are continuous, as we know, but trend rates or slopes are sensitive to the choice of endpoints of the start and the end times. So when we talk about trend rates, it must be in the context of some period which are annotated on the maps itself, the year, the start year and the end year. These trend rates are derived by combining spectral analysis and time series decomposition methods. A two-part paper on this work is currently under review. Also, last October I presented SST trends, and the YouTube link is on the slide if you are inclined to get a recap of the approach and data. But the point here is this data will also be available on the AKH sometime soon. Wrap up the poster presentation now. In summary, with an alpha release in June 2023, follow-up work is underway for the beta release of Coastal Application Knowledge Hub, or AKH, to enable simultaneous displaying of multiple parameters, both satellite and non-satellite data listed here. The beta release will be made in 2024. And finally, the URL is on the top of the poster or the cover slide of this presentation if you want to explore it on your own. And feel free to reach out if you have further questions. So thanks for your attention, and cheers.